and welcome back to DevCon Live 2021 Masterclasses. And right now on the Java Masterclass keynotes, I'm joined by Florin and Wouter from ING Tech Romania. And basically they're going to talk to us about how to genuinely kickstart Azure pipelines with templates yourself. So thank you for being with us.
Definitely. Thank you very much. It's super nice to be here. For those of you who joined our earlier presentation, thank you for giving us even more of your time. We really appreciate it and we couldn't be happier. I know you're very busy and I know there are a lot of interesting sessions today. I will just like, for those of you who didn't join the presentation earlier, to introduce ourselves, to tell you who we are. Why should you spend this enormous amount of time with us when you could, I don't know, watch a football match in 90 minutes or something like that, and then tell you what to expect, so that I don't want to waste anyone's time. Tell you how we're going to do things, we are going to do, and yeah, hopefully we'll have some fun together. Should you have any questions, I understood that they can be asked in the chat and they will be highlighted at a point, and we will do our best to answer. Okay. So I have just 3 slides. So these are the same slides from this morning. I just want to start them because I think it's nice to know who we are. My name is Florin, and together with my colleague Wouter, we are from ING Tech Romania. We are DevOps and engineering leads there. And we have been working together for quite a while now, building Azure templates, and we are responsible for the CI/CD of many applications. Myself, I have been working in IT for what's more than 10 years now. And now in what seems like another lifetime, I have been a system administrator, but around 5 years ago, I switched and became a DevOps. Ever since, I just try to automate everything, and I don't know, hope the people around me are inspired to do the same. Wouter?
Yeah, thank you, Florin. And yeah, thanks for joining. I'm Wouter. I'm, as you probably noticed, I'm not from Romania. So I'm from the Netherlands. I joined ING 4.5 years ago, where I actually started in process automation. And then I continued into continuous delivery, which in the end is also just automation, but then of pipelines. 2 years ago, I came to Romania, also where I started working together with Florin. I'm also now an engineering lead of Tech Romania, and happy to give you this masterclass of what you can all do with templates and how you should use them. I will be monitoring the chat, so please ask your questions in the chat. I'll answer them as quickly as possible. And if there is something that we want to highlight, we will stop the masterclass and we will go over that question.
Yeah, thank you very much. So we promised in the presentation earlier that this is going to be as interactive as possible. So we really hope to achieve that. That's why I think Wouter won't have any problem interrupting me if there's something that is worth noting or highlighting. I think there is just one more slide about ING, who we are. We talked about who is ING. As many of you might know, we are a big tech company. We're also very big. We're also a big bank, but we're also very big in the tech industry. We have a presence in more than 40 countries, and 14 of these are retail banks. We have 38.8 million primary customers and 56,000 people who are serving them. And there's more than 1,000 DevOps teams. And because this is a masterclass, I will now switch to this part, to the Azure DevOps. I should mention that this meeting is going to be recorded. And if you want to see the recording afterwards, because this is going to be some live coding, you can see it at a later time. Also, all the code which is going to be used here is going to be available for you at a later date. So you're going to get both the recording and the code later so that you can retrace these steps. What is to be expected from this masterclass? We will try to get you from, like they say, from zero to hero, from knowing almost or close to nothing. So if you just open an Azure DevOps window today, we'll try to get you in what's more than 1 hour from that to an engineer who can create a template or more, and who can basically create a pipeline based on these templates. So, sorry, the pipeline is going to have either multiple stages, multiple jobs. You're going to know the difference between them. The pipeline will have a build and a publish part. You're going to have a more in-depth look at how code is being stored in repositories, at how the pipeline YAML is defined, and then a pipeline is created, and also where the artifacts are being stored and how they can later be used. This is what's to be expected. Of course, I'm going to do everything from scratch. I do have a backup project here in case things go south. You know, there's always a demo effect in place because live coding, what could go wrong, right? Without further ado, let's start. Basically, just for you, for when you're watching this recording, or if you want to do it live, that's perfectly fine. If you just navigate from your account to dev.azure.com, and you can then log in with your Microsoft account, you're going to be asked to create an organization. You can create organization with any name you want, and then start a new project. And basically, you're going to get this interface. Basically, a project contains can contain multiple repos, multiple pipelines, artifacts, feeds, boards, and so on. Today, we're going to be focusing on a couple of repos, some pipelines, some branch policies, and a way to store these artifacts. Okay, to get things started, the setup I had envisioned, I prepared some code for it, but I'm going to try to also do it live and explain everything I do is we'll have basically a templates repo, which is our main purpose, where we'll have a build template and a publish template, and then we'll have a client repo. The client can be thought as your client, the one who will consume the templates. And from there, we'll try to use these templates to do, of course, a build and a publish pipeline. We don't have enough time to do an entire Maven or Gradle project with a complex POM XML and then some code in order to build the actual artifact. So we'll just mock the creation. But basically, that's just the skeleton of how to do the templates yourself. Okay, so let's get things started. First things first, let's create the first template repo. When you start a new project, you already get a feed, you already get a repo. So we already have a repo called Masterclass DevCon because that's the name of this project. I'm just going to rename it. And I'm going to create the other repo. So let's call this repo client. And then maybe call the other repo templates. Okay, so we have our first repositories. Again, for those of you who are not present in the presentation earlier, Azure DevOps is not just a single tool. It's a stack of tools, so it's basically a concentrator. There's multiple tools, things like repos, where this is obviously a repository like a repository server, like GitLab or GitHub or Bitbucket. You also have pipelines here like Jenkins or Bamboo, and an artifacts server, things like Sonatype or Nexus or Artifactory, where you can store your artifacts. Now, for now, let's focus on the two repos. We have a client repo and a templates one. If I open them in different tabs, I get an overview, so I need the files. Okay, the templates repo is already initialized because I chose it to be so. Let's look at the client. Okay, let's initialize it with a README. And of course, you're going to have an initial default branch, which is main, the former master branch, which is not going to allow you by default to push directly without pull request, I think. And anyway, even if it does allow you to do that, we should maybe create another branch, a develop, because we will be talking about branch policies later, and we will show you how to create a branch policy for any pull request to run some tests. So I'm in the templates repo. I will create a develop branch for both repos out of the main and use that one for my stuff. Okay. Good. Okay, so now we have a develop branch for both repositories. And I told you we're going to have two types of templates. We're going to have a build and a publish. So let's create a couple of directories. Let's say build and template.yml. Basically, the structure, the underlying structure of all Azure DevOps are YAML files, much like Ansible, for example. So everything we need to tell our pipelines to do is going to be written in YAML. Okay, so we have our build template structure. Let's create one for the publish. I have to commit before I do this. So I just created the build because it won't take them. Okay, let's go. Good. Now we have both the build and the publish templates. We have nothing in the build or the publish, so let's try to populate them. And then let's try to call the build template from its first pipeline to see if it actually works. I'm going to show you how to get all the tasks you need from your pipeline. But before I do that, I'm going to write some YAML configuration, and then I will show you where I know to get these things from. One idea I had is for the build to create a mock artifact, and then basically based on this mock artifact, I want it to be published as a pipeline artifact, and then I want to make sure I also try to publish it as in the feed to see it's put there. Basically, the build mocks a Maven build, where basically you can create a jar, a var, an RPM, whatever, and the publish part will put it as an feed artifact. So the build part is going to just create it using touch or something like that, and then it's going to make sure that it's correctly put in the pipeline artifacts. I will do this and then explain a bit the difference between a pipeline artifact, an artifact published as a pipeline artifact, and an artifact published in the Azure feeds, because this happens due to jobs and stages being able to run in parallel, therefore on different machines. So let's start with some parameters. Maybe I should click on edit. And let's give them some generic names. Okay, I'm gonna have a mandatory parameter. So if this parameter is missing, the pipeline will not be able to start. And I'm gonna have an optional parameter, which is maybe the artifact type. So let's say we want something like dot example, not jar, not var, but dot example parameter. So this is an optional parameter. Okay. Now we define them. Let's start. I'm just going to copy the structure so I don't waste time. What happens is that we would like our template to be a stage, and inside it, we are going to run 2 jobs. And I promised you I'm going to explain this a bit. Azure DevOps offers the possibilities of running stages in parallel and jobs in parallel. A stage can contain multiple jobs, and a job can contain multiple tasks. What's the added value here? Well, you can have different stages for publishing. For example, you can have a stage which builds using Maven, and another stage which builds using Gradle. You want these 2 stages to run in parallel. So they will run on different Azure runners, and they will be able to run in parallel. For example, the Maven stage needs to build certain tools. You can have a job which builds all these artifacts, but you can have multiple jobs, and they can also run in parallel. So not only the stage can run in parallel with another stage, but the job can run in parallel with another job. We'll have for today 1 stage per template, and in the build template, we'll have 2 jobs just to highlight this parallelism. Okay, in the steps, I said I'm going to create a mock artifact the way, basically the way Maven or Gradle would create it. I'm going to fetch a task, and I will show you in a few minutes where I get these tasks from and how can I populate them. For this, we're just going to use a simple bash task to create a mock artifact, and I'm just going to loop through some extensions. For example, zip, jar, var, and example. And I'm going to build all of these artifact extensions in a certain file. So let me zoom in the code a bit, because I think it's quite small. So basically what I want to accomplish is I want to mimic the behavior of a build tool, where I want to put in the build sources directory, which is a native Azure DevOps variable, which points to a certain directory. I want to put several artifacts, which are called parameters.foo, which is the name of your mandatory parameter. So if the name here would be Florin, it would create Florin.example, Florin.zip, Florin.jar, and Florin.var. And out of these files, I just want to filter some of them, and I want to publish one of them as my pipeline artifact. So I'm just at first making sure that I have the right files, and then I'm just going to create also a staging directory. But before I do that, I think I have enough in my build template to be able to run a first pipeline. And once I run the first pipeline, I will also show you the GUI interface where you can see where all these tasks come from. So let me commit this first part, and then use basically this example in my client in order to be able to run a pipeline. So I'm just going to create a new file here. Let's call it something super original like pipeline. And in my pipeline, I'm just going to, one thing you should notice is that if you want the pipeline to be named, for example, the number of your build, you can name it as soon as it starts like this. It's a thing I do because I really like it to be named 1, 2, 3, 4, 5, rather than the commit message. Otherwise, they're gonna get the commit message name. And I also don't want this to be triggered automatically on every commit. I will have a trigger none. Of course, as you get more proficient with Azure, you're going to see that you can have all sorts of triggers. For example, you can have triggers based on commits on certain files. You can have cron triggers, or you can even have other pipelines triggering your pipeline, much like in a Jenkins environment, if you will. The most important thing I can do here, because I want to consume templates and I don't want to consume things from this repo, is to call on my resource. So basically, I want to tell it where to look for the templates. So I'm just using the resources capacity of Azure. The repository example here, this is an alias. So let's call it something more original, like original example, just to highlight. This is just an alias and it does basically nothing. The type, which is Git, and then the name, which is made of the project name, which is Masterclass DevCon, and then the name of the repo, which is templates. And last but not least, I want to tell it what branch to use. So I can tell it to use a branch or a tag. So again, we talked about this in the presentation. If you want to use an immutable version, a certain commit SHA, you can tag all of your preferred commits, and then you can use a version of the templates. In my case, I just want to use develop. Okay, this is the repo I would like to use, and then I'm just going to tell it the name of the template. The name of the template, as we remember, let's wait for that to go, was build/template.yaml. If I were to leave this like this, it would look for build/template.yaml in this repo. However, I wanted to use it from the repo, from the templates repo. So I put @ and the alias name. So as you can already see, this is a great way to mix and match between templates which might be local and which might be very particular to your environment. So you might have some templates or some code which only applies to your project. And then you might have some generic templates, some generic build and release templates, which can be used by everyone and which can be used like this, like I'm showing you right now. One last thing I need is the parameters. Yes. Sorry about that. The parameters I will require are just one actually, because I said that the foo parameter is mandatory. I don't give it a default value, while the bar parameter has a default value already of example. So let's just use the foo parameter and say, let's give it a value. Let's call it file, for example, and then it's going to be file dot something, that example dot jar dot whatever. A good practice is to put it under single quotes. And I think this is everything we need for our first pipeline. I don't want to keep you waiting very much for just a very basic pipeline. And now let's hope it works. Odds are it will not, but let's try. Okay, so if you've never done this, it's super simple. You must make sure that in your account you have runners, because it depends on the Azure account, but you must make sure there are runners in your subscription. So there are machines on which this pipeline can run. In our case, we'll be using just one runner now and two runners when we're gonna be running things in parallel. If I click on create new pipeline, I'm just gonna tell it where to find my code. It's in Azure Repos Git. It's in the templates repo, and it's already an existing Azure pipeline. I'm gonna tell it to look on the develop branch, and the pipeline is the build one. And as you can already see, it brought the pipeline I created here. I'm just gonna save it because I want to rename it. As you can see, it takes the name of the pipeline repo, but I'm just gonna rename it DevCon Masterclass pipeline and save. And now I should be able to run this pipeline from the developer branch. Oh, and I promised you one more thing, that you can see where to get the parameters from. So for example, if you edit the pipeline in the pipeline view, not in the repo, you see here you have on your right-hand side all of the tasks that are public in the Azure DevOps marketplace. Basically, this is where I got all my tasks, and we will look how to get more later. For example, when we're going to be publishing this as a pipeline artifact, we are going to get the task from here. So as you can see, it gets the task from here. It has a version, and this is where we can populate it with everything we need. So you don't have to look for them online. You don't have to look for them anywhere. You don't have to write them down. They are all available for you in this GUI interface. So, okay, let's try to run this. For some reason, it doesn't take my full parameter, but we can work with that. So now my build job is basically just going to create those 4 files and just tell me that the build sources directory contains file that something, something, something. And I think we have liftoff. The pipeline has worked. As you can see here, it loops through the extensions. And in our file, it has these 4 files. Because build, this structure, build sources directory, is the current directory. It also has the files which it checks out when the project starts. So one thing to note is that when Azure starts a build, it always does a checkout of the templates repo. So it basically, now we created some files in the same directory where we checked out the contents of the template repo. That's fine because we're gonna move them from here to a staging directory. So this is our first pipeline run. We can see in the pipeline interface the last commit SHA, the short SHA, and that it has run successfully here. You can see where it has run from the templates develop branch.
Quick comment from Bogdan. It doesn't take the full parameter because the pipeline was created using the YAML file from the templates repo, not from the client repo.
Yeah, I think I made a mistake.
Good catch, Bogdan.
We
might have done it on purpose to see if you were paying attention.
From the client, but it's supposed to use the one from the client. No, all right.
It's supposed to use the one from the.
Yeah,
you're right. Yes.
Yeah, it's the client one.
Oh.
I don't know why I didn't take it, to be honest.
We can look into that. So
yeah. Basically, if we take a look here in the client repo, we can see here that we have this configuration, and basically you can also edit your pipeline from here. And oh, you're right, we don't have the same configuration. So good catch indeed. We need to recreate the pipeline. That's a very good exercise. Let's delete this one.
Can maybe explain also to the people why we are.
Yes. So basically, thank you very much for the comment, Bogdan. Basically, what we want to do is mimic the way client would use your product. So you have a templates repository, and then a client would just call on your templates to use them in his or her build. So the templates repository is a repo, a single repo, which is a single source of truth, and the client's repos can be many. So you can have hundreds, thousands of client repos, and they would all be using the same repo here. So I think I chose wrong when I did this. Yeah, I think I chose the client branch develop. And then, yeah, there should be only one pipeline here. There we go. And let's save it. And let's rename it. Thanks a lot for paying attention. Now if we run it, unexpected value index. Yeah, because it's YAML, we need indentation here. Oh, it's template. I think that was fine. Okay. And now, so what it did earlier is basically earlier we, by mistake, we took the code from the same repo. And now we're taking the code from another repo. So we're running the pipeline from this client repo. The structure of the pipeline is this. And we're taking the code from another repo, which is templates, and the structure is that one. And that's true. As you can see here now, it shows the branch used by the client and the branch used by the templates. Perfect. Okay, so let's see if the output is good. It's perfect. All right, then. Let us add more things to our build pipeline. All right. Now we need a thing like copy, because we want to move just one file, the file.example, we want to move it in a staging directory. So if I don't know how the copy task looks like, I can just edit this pipeline and look for the copy task. And we have copy files, which seems to do the trick. And it will look something like this. And if I want a source folder as well, I think I can populate it with some mock code. And basically now I can just add this here and then put the right things in. Okay, that's good. My source folder, in this case, it's the build sources directory. This one I mentioned earlier, where I have all my things, all the extensions. I just want to use the example extension. So in this case, I'm going to use a parameter, something like parameters.bar, because if you remember, the bar parameter has a value of example. So in this case, I want everything with the extension of example to be put aside. A target folder would be something like build sources directory, and let's say example files. I also need to make sure that I create these example files. So let's do that. I'm just creating another folder where I can put my the correct file type. So I'm just gonna put that there. And now let's create another bash, which ensures that only the example file is contained there, and make sure that we don't publish something else. So let's just copy the bash structure. Okay, and let's do an echo in this in the file we created in this one. And sorry, do an ls. Okay, so now we're doing an ls minus LA in that.
One more comments. Maybe you can read it.
Example files. Will not match is set to source directory.
Let me just read the question.
Oh yes,
so
I see
follow.
what you mean. Source folder. Yeah.
So thank you, Bogdan, for.
Yeah, this is the staging one. That's correct. Source folder is source directory and target folder is artifact staging directory. Perfect. Oh, thank you. This is a very nice interaction. Thank you very much. I really like this pair programming, although I really would have loved it to be, yeah, maybe in the same room and people talking.
Maybe also good to clarify, there's a small delay between when we are talking and what you are seeing because of the broadcasting. So it's not always real time. So now we see your questions with a bit of a 10 to 15 second delay. So we were not ignoring you. We are waiting for the question to come in.
Yeah, build artifact staging directory is another native Azure DevOps file path. So it's good for when you're preparing files to be, for example, published as a pipeline artifact, in this case, to put them aside there. So whereas the sources directory is actually the local path where it also does the checkout. The staging directory is the place where it will where we can move files and filter them while we're doing so. Good. Okay, so this will list what we have in our staging directory. I think it's enough for this part. Let's quickly run our pipeline. Which is here. Yeah, let's not save that. One quick tip is if you are on the pipeline itself and you run new, you can run it with the same branch. When we're gonna have multiple stages, you can view them here in stages to run. It's also a nice way to see if you have any problems. And of course, we can have, for example, we can choose the branch we want to use for the templates also from resources. But not to get things too confusing, just run it from here. And now it ought to filter out the example and put it aside in the staging directory. Until it does that, I'm just gonna run a quick if to show you how you can create some conditions. So I prepared this command. Basically what it does, it looks for, in staging directory example files, it will look for the files with the extension var, in this case example, and count how many they are. If there's more than one, more than zero, then it will set this variable to true. Otherwise, it will set it to false. Using this VSO functionality from Azure allows you to set variable which you can later use to put conditions. So in this way, we can later create a task where we make a condition and say, hey, publish this if that's true or if that's false. So it's a good way to use for your conditions later. Let's see what our pipeline did. Thanks again for that comment. It would have failed if we didn't do this. And the last, we can see here that our directory contains file.example. One thing to note is that the staging directory has this path, home vsts work1/s. Sorry, this is the /a. And while as this one, the sources directory is the S. You can see in the Azure DevOps documentation, which we recommend, all these Azure paths and all these variables, what they do. If you look for Azure DevOps predefined variables, you're going to see these two are two of them. basically staging directory is the /a directory in that folder structure. So now, because we know the file.example is going to be there, we know that contains example variable is going to be set to true, and we want to publish this artifact as part of last thing to do in this job. If again I don't know how to publish an artifact, I can always look here and I say publish build artifacts, publish pipeline artifacts, and again I can take the code from here. Publish pipeline artifact is the name of the task. Of course, you can have a look in the help as well. If you look for that task, publish pipeline artifacts, if you look here, there's also a help about this task and page not found. Brilliant. I'm sure others have more help. Let's look for the one we used earlier about this task. Okay, this one has, so this is like, for those of you not who haven't seen this yet, this is the Azure DevOps documentation structure. And for example, for this task, you have everything you need explained. You'll also have some examples and so on. So I highly recommend you use this in case things are not entirely clear in this extension here. Okay, so going back to our thing, we want to publish it. I'm just going to paste it here. So what do? We take the publish pipeline artifact, version 1, that's the one we are given by Azure, and we put a condition here. This is the important part. And let me explain. Basically, the default condition of all tasks in a pipeline are succeeded. So basically, a task runs only if the task before it has succeeded. If we were to put a condition only to this, make sure that the variable contains example, which is this one, is true. Then if this would have failed, or if this was another task and would have failed, this task would have still run. So whenever you start a condition, always make sure you do an and add the succeeded part. This is basically the inherent condition of all tasks. But if you add just this condition, this will supersede the succeeded condition and it will ignore it. So if the task before it fails, this will still run, and we don't want that. So we want to re-add the initial condition and add our condition as well. So we say, hey, publish the pipeline artifact only if contains example is true, so only if the file exists there. The target path obviously is example files, and the artifact is example file artifact. That's just the name we're going to give the pipeline artifacts. I'm going to run this this pipeline, and then I'm going to explain what a pipeline artifact is and what a regular artifact is.
Can you make the font a little bit bigger?
I can.
That one is good, but this one is a bit small.
Yeah, I can definitely make it bigger. So this is what I added. Publish the example file, have a condition here, and publish it as artifact example file artifact in the pipeline. I'm going to run the pipeline now, and then I'm just going to explain what the difference is. So I said earlier there are two types, or I said in the presentation, I don't know if I said it here, there are two types of ways to natively publish in Azure DevOps. One way would be to publish your artifact, your binary, your archive, your whatever as a pipeline artifact. The other way would be to publish it in your feeds, which is basically your artifact server. When you, for example, want to publish something to be used by all teams, either by your team at a later point or other teams to consume it, you publish it in your artifact server, like Sonatype Nexus or Artifactory, you publish it to your feeds. It works basically in the same manner. If you want to cache it between stages or jobs, you publish it as a pipeline artifact. And this is our case. I want to cache this because I want to fetch it again in another stage, which publishes to the artifacts. And why do I do that? I do it because, as I said, stages run in parallel. I have one stage for the build and one stage for the publish. Because they run in parallel, they can run in parallel. They're not going to be running parallel, obviously, because it won't work. They run on different machines. Because they run on different machines, I cannot cache it in TMP, for example. I cannot put it in TMP, my artifact. Because when it runs in the publish, it will not find it there because it's not the same machine. So the Azure way to solve this is to cache it as a pipeline artifact. This can serve caching between stages or caching between jobs, because we're also going to be able to run jobs in parallel, so on different machines. Let's see what our pipeline did. Oh, it finished. So if you look here, you see that now we have one published artifact. And we have the artifact file.example. It might not seem like a big thing, but imagine that if you're going through this course and you do these things on your own, then whenever you're going to start with Azure, even if you do it from scratch, basically you're going to fly through these things that are going to seem super nice and intuitive. And I'm just hoping to explain and demystify them and make them as clear as possible, because they're not difficult, but they might be difficult to understand because there's a lot of information at first. So, for example, you run a Maven build, which produces a jar or a var, and then you want to take this and you want to publish it in your feeds. Well, you can cache it as a pipeline artifact, and then you can download it in your publish stage and publish it in the feed. And that's exactly what we're going to do today. So I think we are done for the build part. I'm also going to create another job a bit later, but right now I want to download this artifact and I want to publish it in my feed. Okay, before I do that, I'm just gonna have to look at what feeds I have. And I don't have any feeds, therefore I need to create one. So let's create a feed called Masterclass DevCon Masterclass feed. And I don't want packages from common sources because I'm just gonna put a universal type of artifact there. It's not gonna be a Maven artifact, it's just gonna be a universal package. So let's create this feed. Okay, I have my first feed, and now I can try to populate it with my artifact I create. Where are we now? So we have a feed, we have a build, which build publishes on the artifact we need in our feed as a pipeline artifact. Of course, you can just publish it directly in the feed, but I want to highlight how things work with multiple stages and multiple templates, of course. So let's say we're finished for now with the build template. Let's focus a bit on the publish template. Okay, let's edit. So what do we want to do? We want to fetch the artifact. We want to create, first of all, we're gonna start with the parameters like the other one as well. But what parameters do we need? We still need the name of the artifact. We need the type of the artifact, and let's say we need a graphical user ID of the feed. We're gonna see why we need this, because on this particular type of feed, we're going to need a user ID rather than a feed name. So I quickly prepare these parameters just not to waste too much of your time. And basically, I'm going to have the same parameter, foo, which is a mandatory parameter, which if you don't mention is going to make your pipeline fail. You have the extension, and then you have another parameter, which is the graphical user ID. Quickly, much like the build, and let me zoom in. Much like the build, you're going to have a stage and a job, but here we have something new. Depends on. What does that mean? We want our stages, which are able to run in parallel, we want them to run in a succession. We want our publish stage to always run after our build stage. Why is that? Because we're publishing something which is later fetched by the publish pipeline. So we're dealing with dependency because we need the publish template to fetch something put by the build template. Otherwise, they could run in parallel. You're going to see cases like I mentioned earlier. You might have 3-4 build stages. You might have Ant, you might have Maven, you might have Gradle. These are all stages that can run in parallel. Or you can deal with a front end, which publishes maybe something for different browsers. So you can have a stage for Chrome, you can have a stage for Safari, you can have a stage for Opera, and so on. And these are, again, stages which can run in parallel. Good. So we have our structure. It's exactly like the structure in the build, only that we tell it that the publish stage should depend on the build stage. And make sure that the name of the build stage is exactly, and I'm going to commit and highlight this, as the name we put here. So you can see here the name of the build stage is build stage. The display name is just a nice name we want to see here when the pipeline runs. So that's the display name is this one, whereas the name here is the name of the stage, and this is the name of the build. So we want the publish to be dependent on the build. And what do we want first is we want to also create a staging directory. We already did this for the build part. I'm not going to repeat it too much. It's just a bash task which creates in the artifact staging directory a directory called to publish, where we're going to download our file. And now what we want to do is download the pipeline artifact. Again, what do you do when you don't know how to use a task or what tasks there even are for what you need to do? Maybe you don't even know what you're trying to accomplish. You just know you need to fetch an artifact, but don't know where to fetch it from. So we're just gonna look for download here. And we have multiple options. You have download artifacts from file share, download build artifacts. This sounds good. And for example, this is the one we need. No, this is download build artifacts. We need to download pipeline artifacts. So if we look for pipeline, this is the one we need. Download pipeline artifacts. There we go. You can download an artifact from a current pipeline, or if you put the build ID, you can download an artifact from an older build, which might, again, prove to be useful. So this is the structure we will need here. I just copied that, and I'm going to paste it here. Okay, this ID is not maybe the best way to do this, but yeah, it will have to do. The build type is current. The target path is the one I created here. And I need one more thing. I need the artifact name. Well, how did you know that? How did you know I'm going to need the artifact name? Well, I looked before this session, or a long time ago, at the about this task here. Doesn't seem to show it. Maybe the publish one shows it, but trust me, there's another parameter needed here, which is the name, which is artifact name, and our artifact is called example file artifact, if I'm not mistaken. Let's see what this build has produced. Example file artifact, that's it. Okay, good. So now, basically, I have enough to go on and to make sure that I can download an already created pipeline artifact. Again, it might not seem like much, but I think it's the idea that counts, how to build and how to release at a very theoretical level, because this is all that time will allow. I'm just going to commit this template and I'm going to add it to my pipeline. So I'm basically copying this template and pasting it here. Will it work? No. Yes, no, no, because this parameter is mandatory. Right now, we don't know the ID of the feed, so we're just gonna leave it empty. But we're just gonna call the template like this. Of course, this is not the build, but the publish template. And again, I'm putting this alias, which points to this repository and this branch. For example, if I were to change the branch here, this would not work because my pipeline is not defined yet in that branch. And that's it. This is everything I need right now. Okay, maybe I need to refresh this and add it again. I'm getting a lot of new errors because I never coded live for so long and for so many people. So thanks again for bearing with me. Okay, and this is publish. Now it worked. We can make sure it worked if we go to the pipeline and if we maybe make this a bit smaller. If we edit, we can see what we just added there. So if we run our pipeline now from the develop branch, we're going to have not one, but two stages, which are dependent on each other. Actually, the publish is dependent on the build, not the other way around. We're not going to have a lot of stages, which is a very complex view. If you know the Blue Ocean view from Jenkins, is going to have a very nice view of what stages are dependent on what. And now we basically just have to expect, I have to expect this to run. In this interface, you can also see the host this runs on. For example, the default one is Ubuntu latest. You can also tell it to use another image. And yeah, it ran, it downloaded the file. Of course, we don't know what file it downloaded. We just told it to download. So let's do that. Let's do an ls and make sure we're downloading the right thing. Again, not much new information here. I'm just downloading another file. Sorry, I'm just downloading the same file, but I'm also echoing and telling it to publish what has been downloaded. I don't even need this grep. I can see everything that is in that file. I'm gonna commit and I'm gonna run this. And then I'm gonna look at how to publish this to the right. Okay, this runs here. Let's open it in a new tab. And now let's make sure we find a way to publish this artifact in our feed. So our feed can take multiple types of artifacts. Of course, most common, you're going to have Maven artifacts here. And the nice thing about feeds is that you can define public upstreams, such as Maven Central. So basically, it's going to act as a mirror for Maven Central. You can populate with your own artifacts that you're creating, which you can consume yourself, or which can, of course, be consumed by your colleagues. So your feed can be then set as an upstream for other feeds. The same way Maven Central is might be an upstream for your feed, and so on. But in our case, we're not going to be dealing with a Maven artifact. We're going to be dealing with an universal package. So just gonna see how to publish that. Universal package, download or publish universal packages. We want to publish. Where do we want to publish? Path, no, from where do we want to publish? Well, let's just copy the thing we have here. This is our path. Okay, Destination feed. Well, the destination feed is the one I just created. DevCon Masterclass feed. The other one is a feed I created earlier this week, just to make sure this works. And our package name should be, let's give it the parameter thing. And because we don't have a POM XML, you cannot increment or change the version. So let it be published with a custom version, or we can put it as a next patch, so it's always incremented. And I think this is it. As you can see here, the feed to publish has an ID, which is this one. I'm just gonna copy this part, and I'm just gonna put it here and explain it a bit more. Okay. So my command is publish. I think that's pretty obvious what it does. Publish directory is where does it take my artifact from. So it takes it from the directory I have created earlier, from the staging directory I have created earlier, which I have populated with the file.example, which again in turn is downloaded from the pipeline artifacts. It's an internal feed. This ID is the feed ID, which I'm gonna use in a moment. And package to publish. This is just foo.bar parameters, the file.example, and version output is going to be patch. So it's probably going to publish 0.1, then 0.2, and so on. And let's give it a description, mock artifact example. One last thing I wanted to do, I said that this is a parameter, so let's treat it as such and commit. If I run this template now, it's obviously not going to work because this is not yet populated. So I quickly go to my pipeline, I edit it, and now I can finally know the ID of the feed here. I look at the run I started earlier, and now I can see if I have in the staging directory the correct file. So you can see I do. To do another super short recap, what I did was I built an artifact, I cached it between two stages as a pipeline artifact, then I download it in the publish section, and then now I'm trying to publish it in the feeds. Let's do that. Let's run the pipeline. And now what I'm expecting is to see the first version in the feeds here. I see the build has already finished. It's nothing much to run, just a few short bash tasks and some copies. Okay, so now let me zoom out a bit. We can see the universal packages task I just added. I didn't give it a display name, so it just uses the name of the task. If I give it a display name here, that is going to change. And now this is trying to publish to the pipeline artifacts. You see here, it's going to be using version 0.01. And in theory, my package should be here. And we have liftoff. We have a package we have created from scratch now in our artifacts repository. Of course, if I were to run this again, because I gave it the patch option, I now expect this to be superseded by version 0.02. One thing to note about feeds is that you're probably not going to be doing so much with universal artifacts, but with Maven artifacts most likely. There's a very nice thing to know before you get started, which is immutability of feeds. So you're basically going to be able to overwrite snapshots, but you're not going to be able to overwrite release versions. So if you have artifact .1.0.0 minus snapshot, you can always overwrite it with the same version or with a unique version, like with a timestamp. But if you have artifact .1.0.0, you cannot overwrite it with 1.0.0. Even if you delete it and you clear the bin, you're not going to be let to overwrite 1.0.0. That is a feature of Azure, the immutability. You're never going to be able to overwrite a release. If you want to change a release, you have to make a new version, either 1.0.1, 1.1.0, or 2.0.0 in this case. So that's something to know until this runs. Maybe it will help you if you're just getting started with Azure, so you don't waste time trying to understand why you cannot overwrite a release. I see it is finished, so if I refresh this, I can see version 0.0.2, so it's working. It's increasing the version. One last thing I want to show you, which I promised, is actually two things, is the parallelism of jobs. So what good does it do to use jobs and stages if we don't use them in parallel, and also branch policies. Let's say that in my client repo, I have finished all my work, and now I'm ready to merge this to master. However, I want to make sure that my code doesn't break. Of course, I don't have any code in master, but if I did, I want to make sure that the changes I'm going to make don't break anything there. I can show you how to do this. For our main, we can go to branches, and here we can use branch policies. And in branch policies, you have a thing called build validation. Because we have a pipeline, we can use it. So in build validation, I'm just gonna use my pipeline, and I'm gonna tell it it's a required expectation to make sure that my code is secure. I'm gonna save this. So now, what does that do? Basically, it will trigger my build validation, my build pipeline publish whenever I do a pull request. So let's try to do that. I'm in the client repo, create a pull request, develop into main, test PR. And create. So as you can see here, it started a build. It's not going to let me, because it says here set autocomplete. If you're less familiar, this means I can set the status I want. I can set it to autocomplete when the checks are ready. For example, when I have all approvals, or when my build has already run. If I wouldn't have this, I would have just a complete button here. So as you can see here, by using that pipeline, I'm just highlighting the point that you can make a very easily integration test for your templates by putting them in a pipeline YAML and using them in a branch policy. We can see that our pipeline is running here. And if it runs fine, then I'm going to be able to merge this code to main. Otherwise, I will not. So I pointed this out in the presentation that integration tests and unit tests are pretty easy to do for templates as well, because basically the libraries of the code, and you can treat them as such. If you have multiple templates, you can put them in a pipeline, do an integration test, make sure they work well with each other, or you can create a pipeline for each template and make sure it runs on commit. We have that trigger none, but you can put a trigger on commit. So whenever someone changes a template, they can find out if they broke something even before they do a pull request. The pipeline has run, and as you can see here, now this has changed status from set autocomplete to just complete because my build was successful. So this is how you can use the pipeline you make also for testing when you merge, for example, or try to merge. Good. The last thing on the agenda today is to see some parallelism of course, I have this, this job here, but how about I have a second job? Which runs in parallel with the first, because that's how they run. If I don't tell it anything, it's just going to run in parallel with the first job. If I don't tell it to depend on the first job, it's just going to run there. And I'm just not going to make anything fancy because you're probably bored already of my voice. I'm just going to do an echo parallel job just to highlight they work in parallel. This looks great. I think this is enough. Parallel, does it have to also one? Okay, so now if we run this, okay, I think we have some indentation problems. If you're using Ansible or if you worked with YAML before, you know it's very, very sensitive to white space. So let me just copy this. It's a very hard to work with IDE. Okay. There we go. Maybe it's better. Okay. Brilliant. So if we were to have two stages in parallel, obviously you see them there. Now we just have two jobs in parallel. So we're going to see them here. As you can see, they're both waiting to start, but they don't depend on each other. So they will start basically in the same time, depending on the runner allocation.
Yeah, and right now it's waiting because of the pool limit.
Yeah.
Yeah, it's called agents are running out of requests.
Yeah. That's because I don't have another agent, I just have one. So you're not going to have one agent, probably, you're going to have multiple. But it doesn't depend on the first job, it's just going to run in parallel with the first one. In this way, you can save a lot of time. Of course, these are not in a succession. You can have jobs running in parallel. It's running this one. The publish stage is going to wait for the build stage to finish, obviously, because it's dependent. And of course, you can also have dependencies among these as well. This job can be dependent on the first job. You can also put a depends on and the name of the first job here. As you can see, it finished. It ran both jobs. This is just a parallel job doing an echo, and which ran in parallel theoretical with the first one. We just had one runner, so that's pseudo parallelism. Okay. Is there any question?
Yes, I have a couple of questions. Thank you for all the questions. I tried to answer all of them, but there were a couple of questions which were asking for examples, so we're gonna go through them now, or I think Florian is gonna go through them. There was one question about the agent pools. Florian already went over that we are currently using the default agent pool. Florian, can you show how we can select a different agent pool?
Yeah, you just have to go to the settings. I think I don't want to show the agent pools right now because I'm not sure if it's confidential or not.
But maybe you can show it in the pipeline where to configure it.
Oh, yes, of course. You can configure the agent pools in the pipeline. For example, let's take this one, for example. It's a good question. Thank you very much. So the agent pools are going to want to configure, obviously, in the templates. If you remember, I said that stages and jobs, they run on parallel machines. So, for example, you can configure, if you have a stage with 10 jobs, if you want all of those 10 jobs to run on a certain pool, you can configure the pool at this level. So here, you can configure the agent pool in this part. I don't know the syntax by heart. I think it's VM image pool, something like this, and the name of the pool. In our case, I think it was Ubuntu latest. If you have a stage like we have here with 2 jobs, and for example, I want my job, my first job, to run on a version of Ubuntu, and I want my second job to run on another version of Ubuntu, or maybe another Linux distribution, I can just configure the second job or the first job to run on another one. Yeah. That's the name of the image, or you can, if you have a VM image, or you can do it with pool. If you want to reconfigure the pool. So I think a pool has multiple images, and you can choose what image to use from that pool using VM image, if I'm not mistaken. And otherwise, if you want to configure a new pool, you can configure it with pool. But basically, you can configure it only in 2 places, at the stage level or the job level, because they run on machines. A task runs on whatever pool the job runs on, and the job, if not doesn't have a pool, runs on whatever pool the stage has. So again, if you configure the pool for the stage, all the jobs and the tasks will run on that pool. If you configure the pool for the job, all the tasks will run on that pool. The next job will run on the default pool or on the pool you configured there. I hope that answers the question.
And the next question, but I'm not sure if we're going to go show an example of it, was about injecting secrets. So I answered this in the chat. You do this by attaching a key vault to your pipeline.
Yeah.
I don't think we're going to go too deep into that because we don't have the time for this. But to explain it very shortly, a key vault is something that you can configure in the portal of Azure. So if you go to portal.azure.com, you will see all your resources there. If you configure a key vault there, you have to tie it to a subscription. And then in your pipeline, you can select the task, the key vault task, which is used to take the keys from the key vault. Now, there are different ways of doing this, but the essence of it is the agent knows about the passwords, about the keys which are in your key vault. You cannot see them yourself, but your agent can. And since the agent is also an immutable set, it will spin up, take the keys from the key vault, and in the end, it also masks them. So if you try to do print key, you won't see them in the logs. And in the end, your agent is killed and the key is also gone.
Yeah, this was just more of a beginner's training or coding session to get you from maybe nothing to a certain level. I think this question is for a bit of more complex users, and we don't have an infra prepared for that.
Yeah, it's also not that much related to the templates, neither for the next few questions, but I'm still gonna quickly touch upon them. One was regarding deployments. So obviously you can do deployments as well in your templates, because in the end, the template is nothing more but a list of steps that you have to execute. How to do this deployment, of course, depends a lot on how you have which runtime you're having. Maybe you deploy to a virtual machine, maybe you deploy changes to a database or to a Kubernetes cluster. The deployment differs hugely, and that this ties a bit to the other question that was in the chat relating to rollback scenarios. Rollback scenarios depend heavily on runtime and how you deploy. So there's not that much related towards templates. I could talk a lot about that because it is also something that we do, but it's not specifically what this workshop is about. When it comes to templates, obviously with the parameters that Florian showed you can insert, you can obviously insert different types of deployment strategies, you can insert different types of rollback scenarios, you can make it as rich as you want. In the end, the templates, yeah, it's a YAML file, but in the end, it's a whole programming interface as well. So you can do a lot with it if you really want. I think this is all for the questions that I wrote down.
Yeah, I think so as well. Guys, you were absolutely on point and answering the questions in the chat. Thank you so much. You made my life a heck of a lot easier. So
thank you too. And thanks everyone for
big thank you for that. Yeah. So again, some questions are gonna keep on rolling because people are a little bit behind with the presentation. Maybe they're gonna check it a little bit later. So we're gonna make sure we get all those questions and get them sent over to you. And of course, you got to stand. They can find ING Tech over on the expo area. And I know you have a little quiz there with some prizes. So everyone watching us, make sure you go there, you exchange business cards, you take the little quiz, and you're going to get into a raffle for some amazing prizes as well over on the ING Tech Romania stand. So thank you so much for being with us, guys.
Thank you so much for having us. And yeah, for the
Guys, welcome to the final masterclass on the Java stage. I'm joined by DB Global Technology and Justin. He's a senior B developer with over 12 years of Java experience. So we brought in the big guns for our final masterclass on the stage. And he's going to talk to us about, well, as you can see, the microservices architecture in real life. Hi, Justin, how are you?
Hi, Sorin. I think I'm good. A little bit nervous.
It will pass.
Thank you.
As soon as we start, yeah.
Thank you for the introduction. There isn't much more to say about me. I have been working for Deutsche Bank for more than 3 years now, and I'm really excited to talk to you about this interesting and very large topic. So let's start into it. I want to show you a little bit, of course, outline, so you know what to expect from this. I'm going to present a little bit about microservices. Don't worry, this is going to take a couple of minutes. I don't want to bore you. I know that most of you probably already know what microservices are, but I just want to make sure that everyone is on the same page with this. Then I want to talk about if it's really worth it to switch or to work on microservices. After that, we will talk about architecture, about pitfalls, problems, and we will do some live coding in the meantime. This will take most of the presentation, and at the end there will be some minutes for questions and answers. Okay, so what are microservices? As you know, traditionally we used to develop a big project that had all the functionality in it in one code base. It used to have modules inside, each module taking care of one of the business subdomain. And this project used to be hosted in a Tomcat server or in some other configuration. It used to connect to only one data store and to take all the data from there. The problems arise when the number of modules started to increase. You needed a bigger and bigger team to maintain the project, to bring new functionalities. And another problem was that if you wanted to scale up the application, you had to scale it entirely. Even if only just 2 or 3 modules were used more than the others, you had to scale up the entire application. So this is where microservices came into the scene. All those modules were taken out of the project and they were deployed independently into some small services. This is where the name comes from. Each microservice has its own code base, its own data store. They only communicate with each other only through the API. The advantages are quite many. For one, each microservice can be scaled up accordingly to its needs. And also they could be assigned to different teams, and each team can have its own set of microservices to develop and to take care of. Okay, so now the question is, does it really worth it? Everybody started talking about microservices for, I don't know, 5, 6 years, maybe more. And a lot of people, a lot of developers started to use them only for the sake of developing in microservices. You know, there's a saying, once you learn to use a hammer, all the problems become nails. In this particular example, maybe a screwdriver would be better for the job. And you would have to ask yourself a couple of questions. For example, is a monolith good enough for the job? If you already have a monolith working and everything is fine, maybe you don't need to switch to microservices. Also, maybe another good question is if the current monolith is going to grow. Do you expect more functionalities in the future? If so, maybe microservices is a good option. If not, you can leave things as they are if they're working good. To use microservices, you have to pay a price, and I'm not referring to money, but mostly to complexity. Microservices can get quite complex. You need a logging mechanism, you need monitoring, you need a new kind of deployment, and so on. So you should really ask yourself if you are going to pay for this price. Another important thing is the speed, the overall performance of the system. In some cases, every millisecond counts. For example, we had a project in our bank where they managed transactions for the stock exchange, and they wanted to optimize each and every millisecond. In this case, for example, I don't think that microservices would have been a good solution. Okay, and now one more thing I would like, before we get to speed, I would like to show you how we can create in Java using just Spring Boot some very simple but effective microservices. Okay, so let's create a new project. Let's just name it first example. We will use Java 8 to show you that there is absolutely no magic behind it, except for Spring Boot. We will be using Spring Web and also Actuator. I will talk a little bit later in a couple of minutes about this actuator and why we need it. Just click Finish. And probably most of you already know have got used to Spring Boot. We already have a running project. We have a source application. We have properties files, even test, and so on. What I would like you to show you is that we can create a controller. Up to now, it's nothing new. I'm sure that most of you know about Spring MVC. So we will use a REST controller. Just void string hello.
Hey, Justin, sorry to bother you, but
Sure.
we forgot a little bit of. We got a few comments here. If you can zoom in a little bit, even increase the font even a bit more. I know
okay.
we've increased it in the beginning, but maybe we can zoom in some more.
Sure, I can try to increase the font.
Mm-hmm.
1 second, editor font. Okay, let's put 20.
Yeah, should be big enough, I guess, for everyone. Because I can see it now in half screen, so I think it's good.
Okay.
Thank you. Again, let the questions in the Q&A, and we'll answer them at the end. So thank you so much.
Anytime there are questions or requests like this, please feel free to interrupt me. I will try to fix them on the fly.
No worries. Thank you.
Okay. We will also use a get mapping. It's hello. So we have the controller. What we need right now is to work in application properties to set the port. So for example, so right now we just need to put server.port is 8080. Let's go like this. I like to first clean compile every project before, and then we can run it. And I will show you some interesting stuff. Okay, it has compiled. Let's run. Let's run the server. So up to now, there is nothing new, but in a few moments, I will show you, I will talk more about the actuator. So the server is up. So we can just put localhost 8080 hello, and we have the message. Right now, if we look at this actuator tab right here, that is also in Spring STS, in Eclipse, and in most IDEs, we can see here there's another sub-tab called mappings. We can see all the endpoints that are running in our application. So we have this hello that we have already used, but we also have actuator and actuator health. Actuator is a module that gives us more information about our project, if it's running, and so on. We can try it right here. For example, we see a lot of information about it. And also there is another important endpoint called health. This health shows all the monitoring systems that our service is up and running. When you have so many microservices running together in the same time, it is very common that some of them may fail. So they should all have this endpoint so they could be pinged and they can respond that they are up and running. We can even get more than this. There are more endpoints, health endpoints, but most of them are disabled by default. If we want to enable more of them, we just have to put something like this: management endpoints, web exposure include. And right here, we can put an entire list. For example, we can put health, we already have, but we can put also info and env from environment. We save it, we restart it. And we will see that in the actuator, we would have more endpoints. We have env now and also info. Let's see how they look like. Env is not much right now. Actually it is, sorry. We have a lot of information like the port right here and many other information, pieces of information. But by default, they are disabled because this is a possible security risk. But you can enable them in this manner. Okay, I will stop the service so it wouldn't make problems for us in the future, and I will return to the presentation. Okay, so we said that the modules that we had before in the monolith are now extracted to some microservices, but we really have to understand that the overall speed is going to be affected. Why? Because right now we have all these microservices communicating through the API, as we have said before. And this means that each call between them is data that has to be serialized and deserialized. Of course, there is some network latency, and all this has to be taken into account. But how can we improve the overall speed? Well, for once, we can try to be careful not to make too many calls in one after the other, but maybe we can get a full batch of data. And there is another interesting idea. For example, let's suppose that when we want to make some reports, and in this case, we have to take into account shipping data. Shipping data also shipping service tries to call payment service, but this call takes a lot of time. Maybe there are a lot of payments, and this is really time consuming. Well, a solution would be to use caching. In some cases, we can cache some of the results. For example, right here, if a shipment has already been completed, then the information about it is not going to change in time. So maybe we can use a caching server like Hazelcast. In this case, after a call has been made with some parameters, if a second call is made with exactly the same parameters, then it will not make the call to the shipping or payment service because everything is now cached in Hazelcast. And we also have another advantage. For example, if the shipping microservice has failed, it crashed, or there's a problem with the network, at least we can partially use the data that has been cached. Let's try to make another live example with this. I want to show you some two projects that I have already created. This is a service that is very, very simple. So we just have an array of 10 strings with usernames and a controller that will get one of these usernames based on the ID. I will just send IDs that of numbers that are smaller than 10. So only one of them will be retrieved. There is another service called user consumer. Second, yeah, it's this one. Too many windows in a crowded monitor. So this service is also very simple. It has it also has a controller with a service inside, and inside the service we just call the service that we had before. So it is nothing complicated. I have just moved all this logic into a service, and also I am trying to call this service 5 times. I try to simulate actually multiple calls. In the user service, we also log every time we retrieve one of these users. So let's just first clean compile them. To be sure that we don't have any surprises, we will run the server. Let's call this server. It's not actually a server, but. And now for the consumer. It's very important. Both of them run on different ports. So the server is running on 8080 and the consumer is running on 8081. So let's just test them. So it's user, and let's put an ID of 5. So we already have a name, it's Alex. Let me just increase the font a little bit. If we look into the service, we can see that we have this action logged. Let's just clear the console for now. The user consumer is running. So let's also test this one. So it's 8081. It's user client, and let's get user number 4, which is George. If we look into the user service, we can see that this event has been logged 5 times because we have made 5 calls. And every time if we make a refresh, we see 5 more calls, even if it's the same information. Now let's try to make a Hazelcast server. This will be very, very fast. So we'll make a new project, this time with Maven, just to show you how simple it is. Let's put a new window. I forgot to put it a name, but it doesn't matter. We'll just have to put one dependency for Hazelcast. Then right here in source, you can see that we don't have any kind of class, so we'll just make one right now. I don't know how to call it. Let's just call it Hazelcast app. You can put any name you want. And right here, we would just put public static void main, sorry, string args. We all know this kind of method. So right now we just need a Hazelcast instance, but right now we have to make a clean install because it doesn't see the dependency. Let's also refresh, and I hope that right now it will see it. Instance. This is funny. This is what live demo means. Oh, come on. Okay, so we have everything set. I don't know what is going on here. Let's just create a new one. Maybe there's something I forgot to put it. Okay, so nothing here. I want to be named just Hazelcast. Server as well. In this window. So everything looks okay. Let me put this back. Let me check if Maven is the correct one. Yes, it is. Clean install it again. I'll refresh the project. Okay. Let's create another class again. Just use copy paste, so I will save some time. Let's see if it works. Yes, now it works. Computers can sometimes be mysterious as well. So this is all we needed. You can see that there is no Spring involved. I just create a Hazelcast instance and that's it. Now we just have to run the main method. And we have already a caching server running. What it is important to see is this part right here. The default port is 5701. we are going to need this when we want to connect the client. Now we will go back to the user consumer, and we want it to use caching. For this, we need to add another dependency to the POM file, which is Hazelcast all. I want to refresh it so it would see it. Now we need to make a cache manager. Or let's just name it Hazelcast cache manager. It's a new class. It's a configuration class. So we would have to annotate it with this configuration. Also, we want to enable caching. This is an annotation that can be put in the Spring Boot application as well, but I prefer to put it right here. And right now I will copy paste again this configuration, which is nothing complicated at all. It's from Hazelcast. This one, Hazelcast again. It's a Hazelcast client instance right here. I think that something is wrong. Hazelcast manager. What the problem is, the name I put is wrong. Is not. Let's name it our cache manager, and this one will be Hazelcast manager. Okay, so right now you can see that the only configuration we've made was to connect to localhost 5701, and that's it. And what we have to do right now is to go into the service and put another annotation that would be cacheable, and we have to put a cluster name. Let's just call it users, and that is it. Let's clean install it again. And restart the consumer. I want to clear the console from the user service. You can see right here that it has connected to our Hazelcast instance, and we can even see it on the Hazelcast server. It says that someone has authenticated from this address. But now let's see it in action. So in the user service, our console is clear, and if we make a refresh right here on George, we can see in the user service that we have that the service has been called only one time. Why? Because it uses cache, even though in the user consumer we have been calling this 5 times, it uses cache. Let's try with another user. Let's try with Alice. We can see in the user service that it has been called, but even though we make multiple refreshes, there is nothing else that is called here. Now, even if we stop the service, the user service, we can see that the consumer still works. But if we try with something that hasn't been cached, for example, with 9, now it will fail because this user has not been cached. Okay, let's stop the services and move on. I think everything is stopped. I hope. Okay, I want to talk a little bit about Spring Cloud. Spring Cloud is one of the members of the Spring family. All of us are accustomed to Spring framework, and we like to develop it. And Spring Cloud brings a lot of useful tools that we can use to develop microservices. It makes uses of annotations, so it is really easy to use them inside our classes. It also supports Google Cloud Platform or Amazon Web Services, Azure, Kubernetes, and has all the common tools needed to develop, as I said. What is important to note is that we don't have to develop Java applications in a Spring Cloud. There are applications that were developed in C#, for example, but use Spring Cloud without any kind of issues. I want to speak about another problem that is can get quite difficult at times when using microservices, and about configurations. When we had a monolith, we used to have only one application file that would host all the properties we needed. But when we have multiple microservices, usually all of them need to have their own application properties file. Now think about if some of these properties are common to all microservices, and at some point we need to change them. We can have 20 or 30 microservices, and this would be quite a lengthy and an awful job to do. Also, for example, someone can make a modification in an application properties and the other developers could not know. It would be very good to have some traceability, to have a history of each application properties. And another issue is that whenever you change something in an application properties, you have to restart that microservice. And this is also something that I can see in my current project. From time to time, one of the developer asks on our internal chat system, hey, is it okay if I restart the user service service? And after that, he has to wait for 5 or 10 minutes to see if anyone replies that he's using it. Another useful thing to use would be to have a configuration service. Right now, if we are using this service, all the microservices can get the properties from that service, and even if those properties are changed, we don't have to necessarily restart the service. Also, we can have a central place where we can change something that is common to all of them. And this configuration service can be integrated with Git or with SVN, so we can have a traceability and a history for the application properties. And what helps us with this, of course, Spring Cloud. And I want to make another live demo. Let's create a configuration server. Okay, so project, we'll use Spring Initializer. Let's call it config server. Again, Java 8. Everything looks good. From here, we need the config server part from Spring Boot, and also the actuator. Sorry. In this window. we have to do is just to put another annotation right here, and that is enable config server. So right now, Spring knows that this is a configuration server. Let's put into the resource folder. Let's make another directory, and let's name it config. Config is the default location where Spring Boot will, Spring Cloud will look for configuration properties. And let's just make 3 files here. And let's put just one simple property called message. Let's duplicate this. Let's make it for 3 applications. This will be the second one. Sorry. Let's put a third one as well. And this would be third application. Okay, so that's it. We also have to put a server port. Let's put 8888. And another important thing to put right here is this configuration here. The Spring profile should be native. And this means that Spring Cloud knows to look for files in locally. Let's try to run this. Okay, let's see, it is actually running 88. Let's put F1 profile default. So you can see that it is running. We have our property right here, which is message, first application. If we go to app 2, we have second application and so on. Now let's try to make a project that would take this properties and property and show it. Let's name it config client DevCon Java 8 as well. Next, for this, we need to get the config client right here. Also actuator and web as well, Spring Web, so we can see the results. Let's try it in new window. Okay. So right now, we just need to let Spring know where to look into. Let's put a server port to be 8080. And we also, one second. We have to put all these configurations. This is very, very important. This is the application name. This will make the difference between all the application, all the properties files we have here. For example, we have put here app1, so it will look into app1.properties file. We have put default profile, the URL, And also this configuration here is also important. Now let's make a controller. I don't know, let's name it message controller. A REST controller. Public string. Name it message. Right here, let's have a string, let's call it str value. And this one will be get from a property. Let's name it message. This will be the property that we have defined it right here with message. And into our method, we will just return str value. And that's it. Let's run it. Oh, I forgot to do something. I forgot to put a get mapping. Let it be message. Okay, and now let's try and test it. So this one is on 8080. Message. We now have first application. But what happens if we want to change the value for this message? Let's say that instead of first application, we want to be something like new value for first application. Traditionally, we would have to restart the web service that we have, but we can do something else. First of all, we need to restart the config server, so it would take the new value for this. And in the client, we need to expose a new endpoint. 1 second. Have to expose refresh as well. Unfortunately, now I really have to restart the server. This should have been done from the beginning. But this will be the only time we would restart this server right here. So right now, if we refresh it, it's the new value because the new value for first application string because we have restarted our first service. But let's just modify this here. Let's put something new and restart this service. Now, how do we get this new property value right here without restarting config client? Well, it's quite easy actually. We just have to make a post request to this refresh actuator/refresh. So we will do just that. And it shows us that the property message has been changed. If we look into config client, it will actually even tell us that it is going to fetch the new values from the config server. And if we just refresh this here, something is wrong. Do we have the config server running? Maybe we haven't put the well, you know Murphy's Law. When you try to present something, that is the moment when it doesn't work. Why it doesn't work. Let me try this from a different browser. Maybe the browser has cached the value. In a different browser is the same thing. This is app 1. Client. This is app 1 again. We have put the refresh. It says that it is getting all the refresh from here. In the message controller, we have the value right here. I don't know why it doesn't work. But it should have worked. I'm not going to waste any more time on this. What I want to show you in the application properties is that we can set here a Git repository, and we can get all the values from a Git repository. I think it is something like server Git, yes, Spring Cloud config server Git username and password. You can put the URI as well. So you can take all the values from Git. If you take all the values from Git, you don't even have to restart this service in order to send the new values to all the microservices. You just need to call that refresh with a post right here, and it should work. Okay, now let's stop the servers and continue with our presentation. Now I would like to continue the theme that we have started a little bit earlier with the resilience. In microservices world, the problem of one of the services, one of the nodes to fail at some point is something that you should expect. So it's not a problem of if, it's a problem of when. And for this have been created circuit breakers. In the physical world, we have all used circuit breakers for our electrical grid at home. When there are too many devices that use the electric grid in the same time, then these circuit breakers just jump and cut the electric workflow, so a fire wouldn't start or to damage some other electrical equipment. And it can have only two states: closed when everything is good, and open. It is a little bit counterintuitive than what we would expect, but try to remember the physics from high school. When a circuit was closed, it meant that electricity was flowing through it, and when it was open, the electricity wouldn't flow through it. Spring Cloud has a module that is called Hystrix, and Hystrix does exactly that. It checks to see if a dependent microservice is up and running. And if it is, then just lets everything flow normally. And if it doesn't, then it will try to implement a fallback mechanism. And this fallback mechanism is in the responsibility of the developer. Like a lot of the functionality from Spring Cloud, this was initially developed by Netflix about 10 years ago, and they heavily use it in their online application. And actually, the name Hystrix is a porcupine that, when it's confronted with a difficult situation, it tries to raise all those needles that it has on its back. So right now I will show you how we can implement some circuit breakers, but I want to have a disclaimer. Unfortunately, there is an issue with my Maven repository, so I cannot show it to you running, but I can show you how we can implement it. Okay, let's create a new project. Actually, no, let's not create a new project, but let's use user consumer that we had earlier. Okay, so right here, what we need to do is to add a dependency in our POM file, which is for Hystrix. I want to refresh the project so we can make use of all the classes that it has inside. What we need to do is just to go to our runner application and put this enable circuit breaker. This will tell to Spring Cloud that it needs to use circuit breakers. And in the service, we can remove this cacheable, and we should put this Hystrix command that has a fallback method. And right here, we need to put the name of a method. Let's call it get username fallback. The trick is that we need to create another method with this name, but it has to have exactly the same signature as this one. So it will be string fallback. It has integer ID. And right here, we can just return anything. For example, we can just return a predefined value like Alex. Let's assume that Alex is available 24/7, and we can just return his or her username. And that's it. This is all we have to do. Unfortunately, I cannot run this and actually show it to you, but what it does, and also you can ask me, why shouldn't we use here a try-catch block? Well, that is a valid point. We could use that as well. But if we use a Hystrix command, it will know that the service is down even before we make that call. So it would automatically bypass all this logic right here, and it will just go to the fallback method. And this can save us some time. This can also be better for the calling service, which may be just overwhelmed with too many requests. And also this Hystrix fallback mechanism is much more powerful, and we can have many more options at our disposal. Okay, now let's go on with monitoring. When you have so many microservices running, it is very useful to have a tool that shows which are running and which have stopped for whatever reason. Maybe you can prevent some crashes or some unpleasant experiences from the user perspective. And if you see that something has crashed, you can do something about it. You can restart it, or maybe look into the issue and fix it before a call has been made. Spring Cloud has a very nice tool that is called Hystrix Dashboard. I cannot show it to you live right now, but I have put a screenshot, and you can find a lot of useful information. What is important right here is this circuit closed, is what I have talked to you about earlier regarding circuit breakers. So if it is closed, then everything is fine. If it would have been a problem, it would have been with red, and it would have written open. And I would also like to talk a little bit about security. I will not get too much into details. This is a very complex domain, a very big domain that can have a presentation on its own. But I would just like to outline some points right here. I want to say that it is a very, very bad idea to just expose all the microservices directly to the outside world. This is very risky because a potential attacker would have a lot of information about our network setup, about how our microservices are deployed, and they can identify which one of them is more important or which one is more vulnerable, and can plan their attack based on that. What is usually done is to have an API gateway that would communicate with the outside world, and it would make all the calls to the relevant microservices. Another important issue is authentication. When we had a monolith, this was quite easy, because if the user authenticated himself or herself, then he would have all the access that we wanted to have. But in microservices world, this is not that easy. We can enforce it in multiple ways. One of them is to include a username and password in the header for each call, but this would mean that we would have to manage users and passwords by ourselves. Another method would be to use certificates. But after a while, these certificates usually expire and need to be renewed. This would be quite hard for us to do every now and then. So I don't think it is a very good option. What most people use right now is to use an authentication server. If you do this, you delegate all the responsibility of authentication to one entity. And how this works is like this. For example, we have a user, is the laptop on the left. So it would send a username and a password to the authentication server that may be external, maybe it can be a third-party component. And the authentication server will reply with a token. This token has a period of availability. After that period, it will expire and the user has to generate a new token. After that, when the user tries to call a service after it passes the API gateway, each service should have the responsibility to check that token. How it does that? It would send that token to the authentication server and it would ask the authentication server if the token is valid. And the server would respond with okay, or it's not okay. And if everything is okay, then the service can continue and fulfill the request. What is really important to note is that the security should not be led only at the API gateway level. No, actually, it should be done on each microservice. You can increase significantly the security level of your entire application. This is called security in depth. And that's mostly it. Please let me know if you have questions. I know we have finished a little bit earlier than was expected.
No worries, just in time. Yeah, we got a ton of questions. I was looking at the chat right now. Thank you so much for the presentation. It was really, really good. And I'm not a technical person and I got some stuff from that, so. All right, I'm just gonna go all the way up and I'm gonna start with the beginning. First question is, how can you convince your company that the current monolith continues to grow and the project structure is not very good?
Okay, that's quite a difficult question because there's not an answer for all situations. But what I would try to do is to try to create a proof of concept. Usually when you already have a monolith working and you want to add a new functionality, you can create a new microservice for that functionality, and you can make the monolith and the new microservice or microservices to communicate together. This is a gradual change, a gradual approach change. Usually people and management in particular, are quite reticent. I don't know if reticent is a word in English. Don't really like sudden changes. When you change everything all of a sudden, is not very appealing to them. But you can make this change step by step.
Okay, so gradual change will help people in charge of stuff like that.
Yeah,
not everything right away. And I think a little bit related to that question is this one: migration or rewrite projects. I know it depends, but I wanted to know your opinion.
I would say migration. If you rewrite everything from zero, it would mean throwing away everything that you have worked maybe for a couple of years or even more. As I said just a moment ago, if you make gradual changes, it would be easier to be accepted by management, and it would also be easier to develop by the programmers. There is another idea, for example, that when you create a new project and you have microservices in mind, that you shouldn't create microservices from the start. You should create a small monolith and use it until all the boundaries, all the business boundaries are clear, and until all the requirements are clear from everyone. Especially at the beginning of the project, requirements can change quite a lot. The client usually doesn't know what he really wants. And if you take this approach with a small monolith, and after you gain some experience on the project, to break it into smaller microservices, usually you have more chances of success. So I would suggest again small steps, a gradual migration to microservices, and not change everything at once.
Okay, cool. So I got another question. I didn't want to interrupt you whilst it was written down. It's really cryptic. It's javax.websocket.server.path param. Why? Basically, this is the whole question.
Sorry.
I think it was related to something in the beginning, whilst you were coding. It was basically a syntax. So it's javax.websocket.server.path param. Why?
Socket? I don't think I don't know where it was. I don't remember it.
Yeah.
So maybe.
Yeah, it was, I think, in the beginning, but we can maybe if George knows where it was, he can write a new one here. Okay. I think he's writing down something. Just a sec. Oh, I guess it was a wrong import, something like that. Okay.
Oh, okay.
And now we got a big one. Let's say we work in a company that has tens of microservices. It's written down in more. Let's say we work in a company that has tens of microservices and we have two teams. We'll keep going. Would you choose both teams to work on a few microservices, let's say 50-50? Or you'd choose both teams that should have hands-on experience with all of the microservices so they are familiar with all of them?
No, I wouldn't choose the second approach. The first one is much better in my opinion, especially for new joiners. Even if they are experienced developers, whenever you join a new project, it takes some time to get accustomed with the project and everything. Usually, the tendency is to allocate projects to teams, but not teams to projects. On a project, on a microservice, there should be one team only that should take care of it. They should take the responsibility, and in this way, you can make sure that they don't step on each other's toes.
Okay.
They don't collide when someone makes a change. The other ones don't feel it if they have separate microservices in charge, so to speak.
I got it. So not mishmash them and just allocate specific things to specific teams, right?
Yes, maybe not necessarily 50-50, because some microservices could be more complicated and maybe they require actually more attention and more people. Okay,
so maybe 50-50 in terms of workload then.
Yeah, exactly. Yeah.
Cool. We got another one. Why Hazelcast and not other solutions for caching? Pros and cons.
Hazelcast is something that I have worked on, and it is quite simple to set up. I proved today that it just took me one line of code effectively to make it run. But it can be anything. If you are accustomed to something else, even Spring, I think Spring Cloud has caching inside a cache server embedded inside the framework. So you can use that as well. You can use anything you want.
Okay, so is there any downside to Hazelcast, or just anything that gets you annoyed by?
No, I didn't have the chance to get annoyed by Hazelcast. Okay. It's quite robust. Is fast. Can be configured to do lots of stuff. I mean, you can even tie it to a database if you want to have some persistent data as well. And it's really, I don't know, I really liked it. I didn't have the chance to work with anything else, to be honest, right here. But I think it's good enough.
Oh, okay, cool. And another one, we've got tons of questions rolling in, and I'm pretty sure they're going to roll in even after we're finished. So we're going to compile everything and send them over to you.
Okay.
So in the context in which you work with many microservices, do you prefer working in a local environment like Docker/VM or in a cloud environment while developing?
I like in a local environment, but this is personal preference. I think that you have more flexibility when you are local. But again, it's personal preferences. Some other people might argue against it.
Okay. Is there a speed thing as well when you work local? Maybe everything goes faster, the whole process, you don't have to wait for anything, or?
Oh, yes. Well, that depends. Right now the cloud environments are quite fast, and I don't worry about speed anymore. But usually I think that in general you can do your job faster locally when possible.
Okay. Cool. And another one, are there any design patterns you would always choose when you start a new microservice project?
Well, that's a tough one, right? I don't know what to say. Well, it's not really a design pattern, but you should always remember that everything is distributed with all the benefits and all the bad things that it has.
Okay, scrolling down. Now we've got a little input. Refresh scope on the REST controller was missing, I think, when we had a little error earlier.
Oh, okay.
Yeah, awesome. They were on point here. Got a very nice. Okay.
Yeah, forgot about the refresh scope.
Is the session recorded? Can we have access to the live session afterwards? Of course, it is recorded right after we finish. After the event finishes, you can go back and rewatch, see everything we've got thus far.
Yes, that is correct. Sorry, I don't know if my screen is still shared, but indeed,
yeah, it's still shared.
We had to put a refresh scope right here.
Florin was on point. Let's see if it works.
Thank you. Yes, we
Thank you so much.
Try. But yes, this is what was missing. Sorry when you have so many eyes on you, and on what you do during live coding, you can forget and overlook lots of things.
Yeah, it happens. No worries. From what I know, Hystrix is under maintenance over at Netflix. Other circuit breakers implementations are recommended. You got another comment here.
Okay. Maybe that.
Okay, I think that sums it up. I'm just going to look into the pending. Okay, awesome stuff, awesome presentation. Thank you, guys. And again, Justin is to thank for this.
Thank you.
Yeah. Okay, cool. Thank you so much. Again, we still have questions for you, Justin, rolling in, but we're going to compile them and send them over to you whilst everyone finishes watching the presentation. So thank you so much. Thank you, DB, for being with us, DB Global Technology. And of course, don't forget to check their stand, go over in the expo area and exchange some business cards, get in touch with the peeps over there. And again, thank you so much for being with us. And I'm pretty sure you can find Justin around, especially tomorrow in the event, just to get in touch with him as well.
Sure.
Thank you. And this concludes our masterclass stage. And I'll see you tomorrow, guys.
Okay, thank you.
See you.
Have a nice evening.